Hello, in this video we'll be looking at line graphs and how to draw line graphs. Now, I've prepared this for you. Okay, let's get it straight. That's better. So, what I've got here is I've got values of f. So we've got f, which actually stands for force, but it doesn't matter. F there, we've got some values there from 0 to 6, and x, which stands for extension, but again it doesn't matter, just two values from 0 to 12. Now we're going to decide what those fx are. Now we're going to just say, okay, well, let f be on the y-axis and x, well, that's nice and easy, we'll put that on the x-axis. Okay, so, and we've drawn the graph here. It's got f here, which is, if you like, force. Let's be specific. Let's say that's force in newtons. Let's say that's extension in meters. So the force goes 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, all the way up to 6 newtons there, and extensions 2, 4, 6, 8, 10, 12 meters. It's unlikely. It's going to be very, very rubbery, very stretchy stuff. Now, what I've done is got a series of these values here, so 0, 0, 2, 4, 3, 5, 4, 9, 5, 10 and 6, 12, and I've plotted them on the y and the x-axis, just like that. Okay, and of course 0, 0. Now, what I'm going to draw now is a single straight line of best fit. Now you see, we're not going to join them all together, like that, like dot to dot. That doesn't work. So often in other subjects you go up, down, across, down. You join like that. Not at all. You can draw one line that's going to go through the middle. Now we see here the trend line seems to be going through there, with that point above and that point below. So that's what we want. And we're going to draw it just like this. Now it's pure coincidence that it's going to go through any points at all, but in this case it will. And I'm going to try and draw a straight line freehand, because I haven't got a ruler on me. But that's no excuse for you. Always use a ruler. So here we go. Okay, that's not bad, but that's years of practice. And as you see, it goes more or less through those 3 points, but doesn't hit those 2 points at all, which is absolutely fine. Okay, so this is my line of best fit. It also goes through the origin. Now, it doesn't always need to go through the origin, but often in physics you'll find that a straight line will go through the origin unless there is something called a systematic error. And we can talk about that another time. So there you are, I've drawn my line of best fit. It is an average. And what do we do it for? Well, we do it to look at the trend, but we also do it to find the gradient. So if you remember from perhaps a previous video I showed, or something else, the formula for a straight line is y equals mx plus c. Now, in this case, the c is 0, and often in physics the c will be 0. So what we have here, we have force F is equal to the gradient m times x plus 0. So force equals mx, where m is the gradient. Now, to find the gradient, what we do, again, we take a large triangle. And let's take that triangle. From any 2 points on the line, I'm going to choose 0, 0, and some of the values. I'm going to use 0, 0, and 12, 6. We don't have to. We could use any points as long as they're a long way apart. So we find the gradient m is equal to the change in the y-axis, which is change in f, which is 6, divided by the change in there, that's 12 minus 0, that's 12. So the gradient equals 6 over 12, which equals 0.5. So we could write the equation as f equals 0.5x, and that is the equation of that line. Now, in fact, that is in fact a demonstration of Hooke's law, and Hooke's law says f equals kx, where k is known as a spring constant. In this case, the spring constant here for this material, and it could be a spring perhaps, is in fact 0.5. Okay.